All right, so we're continuing with our factoring. Number 33, what we have here is, well, first factor, we're going to look for a GCF. Part A, no common factors. So what makes this one a little bit different is it's just two terms. It's still an x squared polynomial, but with only two terms. So you could approach this two ways. Some of you guys like to do this where you fill in that missing term. You say, oh, well, if we don't have that middle term, I can write in a 0x and factor with that. So if that's your preference, go ahead and factor with that. Do you have factors of negative 25 that add up to 0? When I have two terms like this, I recognize it as a difference of squares pattern. So let me just talk through the pattern of how this will factor. Um, so we have two terms with subtraction. So we're finding the difference of, are these perfect squares? So x squared is a perfect square because x times x is x squared. 25 is another perfect square because 5 times 5 is 25. So when we recognize that we're looking at a difference of two perfect squares, it will factor into this binomial factor pattern every time. One binomial factor is an x plus 5, and the other one is an x minus 5. Done. All right, part B. First, we look for a GCF. I can see that they all have a common factor of 5, so let's factor a 5 out. Make a note, GCF equals 5. Factor a 5 out of each term, so we have 5 out front. When we factor 5 out, we have x squared plus 5x plus 6. All right, now let's continue factoring the trinomial on the inside, or at least try. So this is a trinomial. Also, how do we feel about this GCF? Do these terms inside have any common factors, anything in common? Nope. So we are going to feel good about our GCF. We know that we got the correct GCF. Now our trinomial is an x squared trinomial, which means we can jump right to our C value. Factors of 6 that add up to 5. So our factors of 6 are 1 and 6, 2 and 3. We're looking for a factor pair that adds up to 5, and that's that 2 and 3. So our binomial factors will be x plus 2 times x plus 3. And let's not forget that GCF is a factor that comes down and is part of our final answer. All right, number 34. More factoring. All right, so first we look for a GCF. There's not a GCF here. This is an x squared polynomial, but with only two terms. So again, if your preference is to fill in your missing term, you can go ahead and factor the trinomial x squared plus 0x minus 16. But the factoring pattern that I like to think about is we are taking the difference of two perfect squares. What do we square to get x squared? X times x. What do we square to get 16? 4 and 4. So we're finding this is the difference of two perfect square terms. So that's going to factor into an x plus 4 times an x minus 4. So the reason why I really like the difference of squares pattern is when you recognize you're looking at a difference of two perfect squares, it's a very quick factoring pattern. All right, part B, we're looking for a GCF. No GCF here. It is an x squared trinomial. There's not a number in front of your x squared, so we can jump right to our C value. We're looking for factors of 100 that add up to our middle term of 20. So we could go through and list all of our factors of 100. When your C value, or when this is a bigger number you're trying to find factors of, a quick factor you can check is if you could take the square root of 100. If 100 square roots, which means it's a perfect square, so square root of 100 is 10, that means that 10 times 10 is one of our factor pairs for 100. And we're looking for a factor pair that adds up to 20. And not every single time, but sometimes that square root we found, that just might be the factor pair we need. So I checked it first. It's a real quick check. Because I found that's the one we want, I don't have to list all of my factors of 100. That would just be too time consuming. So the factor pair we want are 10 and 10. So our binomial factors are x plus 10 times x plus 10. And then when we have a binomial factor multiplied by itself, we can just simplify that one step further and say x plus 10 squared. All right, more factoring. Okay, so part A, do we have a GCF? We look through here, anything in common with these three terms? There's no GCF. This is an x squared trinomial, but with a number in front of the x squared. So we are going to factor this with a box. So let's go ahead and draw our box and fill in the 3x squared. Actually, I'm just going to, okay, a little bit bigger, I guess. And then we know that the negative 8 is going to go bottom right. Now, when you're factoring with a box, if there's that 3 in front of the x squared, I can't look for factors of c that add up to b. That we won't find factors that work. So remember what we do is we have to do a times c. It has that extra step of the a times c. So a times c is 3 times negative 8, which is negative 24. We're looking for factors of negative 24 that add up to a positive 2. So your factors of negative 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. The 2 and 12 factor pair is the one that's going to get us to this. No, it's not. Not the 2 and 12. Actually, we want the 4 and 6 factor pair. We need one of these factors to be negative because it's going to multiply to a negative 24. Now, if you're listing all your factors of negative 24, perfect. Please do that. The more that you factor, the less you will need to do that. So sometimes I just jump right to the factor pair we're looking for. I almost went to the wrong factor pair, but I thought twice about it and knew we would need the 4 and 6. All right, so because these factors have to multiply to a negative 24, one of them has to be negative. Which one should be negative so they add up to a positive 2? We're going to need the 4 to be negative. Again, your larger factor will have the same sign as your b value. That's another approach you can take on that. All right, so let's fill in the negative 4 and 6. We're going to include an x, negative 4x and 6x. All right, so we're going to pull out our common factors. So 3x squared negative 4x has an x in common. Next row, 6x and negative 8 has a 2 in common. Let's pull common factors up to the top. 3x squared and 6x has a 3x in common. And then negative 4x and negative 8, let's pull out a negative 4. Do a quick check. Is 3x times x 3x squared? Yep. Negative 4 times x is negative 4x. 3x times 2 is 6x. Negative 4 times 2 is negative 8. Okay, so that all looks good. We can put our answer together. We have 3x minus 4 as one of our binomial factors, and the other one is x plus 2. All right, part B. What are we going to look for first? A GCF. There is no GCF, so we're going to notice this is an x squared trinomial, but there's a number in front of the x squared. That means it's factoring with our box. In the top left corner, or top left box, we're going to put our 8x squared. Bottom right corner is our positive 5. Now, we're going to find, we have to do a times c. We have that extra step, a times c. So 8 times c is 8 times 5, which is 40. We're looking for factors of 40 that add up to a negative 14. So factors of a positive 40, we can have positive factors or negative factors, and we need it to add up to a negative 14. So just thinking through my signs, I know we're going to have two negative factors. And what are factors of 40 that add up to 14? It's going to be a 4 and a 10, but both negative. That's how we get that negative 14. They still multiply to a positive 40. So we'll go over to our box and fill in a negative 4x in one box and a negative 10x in the other. Now let's pull out our common factors. So top row, 8x squared minus 4x. We can pull out a 4x. They have that in common. Negative 10x and 5. We can factor out a 5. Oops. All right. We can factor out to the top 8x squared, and negative 10x has a 2 and an x in common, so 2x. And then negative 4x and 5 have just a 1 in common. All right, so here's one where we're going to check our signs on this. So is 2x times 4x 8x squared? Yes, it is. Is 2x times 5 a negative 10x? It's not. 2x to get this to be a negative 10x, we need to bring in a negative. Well, we know that we want both of these to be positive because that's how we get that positive 8x squared. So why don't we go ahead and make this a negative 5? So it's 2x times negative 5, negative 10x. There we go. All right, how about 1 times 4x? Is that negative 4x? That's not. So why don't we bring in a negative with that 1? Now let's see, does that work? Is negative 1 times 4x negative 4x? Sure is. And then to get this positive 5, is negative 1 times negative 5 a positive 5? All right, now it's all working out. So our binomial factors, one of them is 2x minus 1, and the other one is 4x minus 5. All right, so number 36, we're going to state the degree. So when we state the degree, what we do is we find the sum of our exponents for each term, and then whatever the highest sum is the degree of the entire polynomial. Now for part A, we only have one term. This is a monomial. So what we're going to do is we're going to add the exponents together, 3 and 4. 3 plus 4 is 7, and that is the highest exponent. We don't have any other terms to add our exponents with, so this is our degree. That monomial has a degree of 7. All right, 15m squared n to the 7th. There's another monomial. So we will just add our exponents. 2 plus 7 is 9. So this monomial has a degree of 9. All right, number 37, write the polynomial in standard form. So standard form is just proper order with making sure all your like terms are combined. So proper order will start with the highest exponent, and your exponents will go in descending order. So what I do is I do a quick scan to find the highest exponent, and I can see it says x squared. Are there any other x squareds for this to combine with? There aren't. So that 9x squared is going to be our leading term of this polynomial. Now I'm going to go in descending order of exponents. So I'm going to look for anything that's x to the first power. Here's an x to the first power. It doesn't have any other x's to combine with, so that positive 9x is going to be my second term, plus 9x. So we've got x squared, x to the first. Now we look for any constant terms. Remember, your constant terms are the ones with no x's, and we do have this minus 8, so that will be the last term of our polynomial. So this has 3 terms, so this is a trinomial. And if we were to think about what the degree is, just to show some more degree examples, if we look at one term at a time, if we add our exponents for this first term, we would get a 2. Add exponents for your second term is a 1. This last term, constant terms always have a 0. What's the highest exponent? It would be this 2. So this is a trinomial. We're just giving extra information with a degree equal to 2. All right, part B. Standard form, look for your highest exponent. We have this y to the 6th. Do we have any other y to the 6th powers that it will combine with? We do not, so that 4 y to the 6th will be our first term. Now I'm going to go in descending order. I'm looking for a y to the 5th. We don't have any of those. I'm going to look for a y to the 4th. Nope. Then a y to the 3rd. Oh, right there. We're going to subtract y to the 3rd. After y to the 3rd would be y to the 2nd power. So I look for any y squareds. All right, we have one of these on the end, so that's going to come next. Plus y squared. Now we're looking for a y to the 1st power. Oh, right there we have a minus 5y. And then look for any constant terms, 14. It is a positive 14, so we're going to say plus 14. And this is standard form.